So shall I start introduction? Okay,
Sure.
okay. So let me, so hello everyone. I'm Wei, this SLS talk host, and we are very fortunate to invite Xuan to as a presenter to present his recent work. And let me first make a brief introduction about our SLS talk. Our SLS talk provides a platform to share the research work conducted by graduate students and learn research ideas from peers. And our secular presentation topics are mainly from our different ICSE labs. And our presenter is carefully selected as well. And this event is aimed for graduate students of NTU, but all are welcome. And also for students with GAP hours requirement, this event can be counted as 2 GAP hours for present as a bonus. Next, I need to introduce today's presenter, Xuan Fei. He is a PhD candidate in computer science in Nanyang Technological University, Singapore. And his research involves various topics of deep learning, neural machine translation in NLP. He tries to innovate and invent novel models and architectures such as the transformer to improve the performance of data-driven machine translation system. He also exploits numerous techniques to enhance unsupervised and semi-supervised machine translation systems, such as using diversification methods. His work can meaningfully contribute to the development of commercial translation systems like Google Translate. In this talk, he will introduce a novel component to the standard unsupervised machine translation framework called Cross-model Back-translated Distillation, named aka CBD. CBD is applicable to our previous unsupervised machine translation approaches and achieves the state of art in various unsupervised translation talks. Okay, I will pass the microphone to Xuan Fei. And are you ready?
Yes.
Oh, great.
Yeah. Okay, thank you, Wei.
Yes, thank you.
Okay, so hi everyone. My name is Phi. Today I will present our work called Cross-model Back-translated Distillation for Unsupervised Machine Translation. So this work has been published in ICML 2021. So let's start. So let's talk a little bit about data diversity in unsupervised MT. So essentially different from the standard supervised MT models, unsupervised MT model is trained so that the model is capable of generating diversified synthetic data during training. So currently there are 2 existing mechanisms for this. The first is denoising autoencoder, which essentially means that we randomly noise the input sentence and make the model reconstruct the original input. And the second mechanism is iterative back translation, where we use the model to translate and train it via back translation. So although they are pretty effective, we believe that they may have reached the limit in terms of how diversity that this mechanism can generate after training. So based on this, based on these intuitions, we try to propose a new method called Cross-model Back-translated Distillation, or CBD. So this method essentially uses 2 standard UMT models, or 2 standard unsupervised models, theta 1 and theta 2, to generate synthetic data for a new supervised model, theta, to train. So, which is the final model that we want to do. So the data generation process will look like this. So for example, let's say we have big XS and big XT as the 2 data distribution represented by the monolingual data for the source and the target language. So let's say source is English and target is German. So in the source side, we sample data XS from big XS or the English monolingual data. And then we use the UMT model theta alpha to generate or to translate this XS from English to YT in German. And then we use the model theta beta to generate the results YT back to English. So which is called right now called ZS. So please note that the model theta alpha and the model theta beta has to be distinct and different. It can be of the same architecture, but they have the parameters and the weights must be different so that they are pretty much distinct from each other. So after this process, so we essentially obtain 4 bidirectional parallel data pairs. So XSYT, YTXS, and YTZS and ZSYT. So we use all 4 pairs to train the target supervised model theta. And we do the same thing for German on the target side. At big XT from big XT, we do the same thing by sampling XT from big XT, and then use the model alpha to generate YS, and then use the model beta to generate from YS to ZT. And then we do the same thing. We train all the models on the target supervised data, so supervised model. So this design is what we call cross-model back translation, because the model theta alpha and the model theta beta has to be different. So we just call cross-model. So so if you look at the overall training algorithms, you can see that previously we pronounced we have 2 models, theta 1 and theta 2. So what this means is that in the training process, we alternate theta alpha, theta beta as theta 1, theta 2, or theta 2, theta 1, so that we switch the role of each theta 1 and theta 2. So so let's talk more about the experiments. So in the WMT, the standard WMT unsupervised experiments, our method essentially achieved the state of the art in all the language pairs that involve English, French, German, and Romanian. And so to understand the benefit of the new method, cross-model back translation, we try to compare our method with a similar versions of our method, except that we do not use 2 distinct models, theta alpha and theta beta. Instead, we use only 1 model, theta alpha only, to generate data in the same 2-stage generation process as we use in CBD. So we call this variant BD. As shown in this table, BD barely make any difference compared to a standard NMT baseline. And however, our CBD method outperform all of them by large margins. And the improvements here must come from the fact that the 2 models in the first stage and the second stage must be different. So if they are the same, then they may not give a good improvement. So so we also do another analysis on the data diversity that our model is able to generate. So in this analysis, we measure the reconstruction BLEU, which means that we use the model to generate from the model alpha theta alpha to generate from English to German, and then that result from German back to English using model theta beta, and then we measure the difference between XS and ZS, which is the difference between the real English and the fake English that the model, the 2 pairs of models have generated. And this table shows that the BLEU score for CBD is much lower than BD, which means that the fake English ZS is much different from the original XS, which means that the model is the generated data has become more diverse or more different from the original data. And we also measure the ratio of duplicate pairs in the total amount of data. So this measure how much the total generated data end up as the same as the original data. So it shows that the amount of duplicates only accounts for around 14% of the total data, which means that the rest, or around 85%, is actually diverse data that the model, our method has been generated. So it means that there's a lot of new data has been created out of thin air. So in addition to that, we also measure compare CBD to other diversity related methods like top K sampling or top P sampling, which essentially using random sampling to generate synthetic data. And also other methods like multi-agent dual learning, which also use 2 models like us, but in a little bit different way, and which shows that CBD also outperform these methods as well. So yeah, so I think that's the end of our methods, which are pretty simple one. Yeah. So yeah, you guys have any question?
Okay. And okay, this all is very short. And
yeah. Sorry.
No problem. So audience, do you have any questions for this talk? Because this talk is too short, and maybe can you elaborate your why do you choose this topic as why do you think this topic is worth in exploring? And
Sure. So essentially, first is let me talk about the rise of unsupervised MD. So the first motivation is that supervised MD has been maturing. So they essentially outperforming or achieving near human level performance for high resource languages, but they are still underperforming on low resource languages, like Southeast Asian languages or Indian languages, like Tamil and Nepali and so on. So there has been a really high push in unsupervised MD. So that's the thing that unsupervised MD has to be pushed forward. And so the specific motivation behind this work is the fact that the overall idea of unsupervised MD has been to generate as many as diversified but accurate synthetic data as possible. So because we doesn't have labeled data, we have to generate them. So so the more randoms, the more diversified the synthetic data that we are be able to create it, the better the model will become better. Also because the fact that neural networks are very much data hungry. So given a very limited amount of supervised data, we need to generate as much as diverse data as possible to train the model. So in that way, we hope that the model will improve better. And so another areas that I think we also be focusing on is pseudo parallel data mining, which means that we doesn't have labeled data, but we try to find labeled data in the monolingual data, which means we are trying to from a pool of monolingual data. For example, English and Germans, we try to find a method so that we can mine data, parallel data in it. So for example, we find translation in monolingual data, and we use that pseudo parallel pairs to train the model, so that in this way you can improve the model even better.
Okay. And a further question, and because your research your research is NLP related, and okay, we have a question from John. Any limitations of your design?
So essentially, there's a few some limitation. The first is we essentially have to use two distinct UMT models, which essentially add up to the cost. So it almost we need to train two standard UMT models to do this. And the second the second limitation is that at this form, the method is not able to scale, which means that the more distinct models that we use, we got diminishing returns. So we try using 4 or 8 models, UMT models, to create even more synthetic data on it, but we observe that performance does not improve very much. And that's essentially the effect of diminishing return. And which also means that we go back to the same motivations that our method is also like it is reaching its limit in terms of generating synthetic data. And also there's another caveat is that we our method is still a noisy way to generate synthetic data, and a better way is probably to do it more accurately. So for instance, if we try to create as much as synthetic data as possible, then we may go into the situation that the synthetic data may not be accurate enough to improve the UMT models. So we may have to do something else, such as mining real parallel data and train the model on it.
Okay.
Yeah.
Okay. Sure. We have a further question from Major. Sure, is selected data reliable with regarding to producing a good model?
Yes. So the synthetic data at certain limits, it is reliable. For instance, if you can observe, like in the history of unsupervised MD, we has been using synthetic data all along. For instance, we have like denoising autoencoder, which is we just randomly noise the input sentences and make the model try to reconstruct it. Or iterative back translation is making the model train on the synthetic data created by the model itself. So the model is essentially trained on its own product. And our method also fall into the same categories. So as I mentioned before, I think it may come to a limit that the synthetic data, it has become, if it increases too much, then it may increase its noise, and the noise will also hurt the models because the synthetic data may not be accurate or as good as human generated data in a sense.
Okay. Could you okay.
A little bit about the results.
Yeah.
So I will go back to the main results. So this is the main results. So we compare our method with some previous state-of-the-art methods like XML and MAS, and we observe around like 1 to 2 BLEU improvements in these languages. Also, another caveat of this method is that we have not explored in a really low. We haven't explored much in the realm of low resource languages like Nepali and Sinhala or Malay and so on. So which is actually the real target for unsupervised MD, because all these languages are actually very high resource languages, and they have a lot of label data already, and the supervised model are very powerful. So this is like a step forward, but not essentially the way we completely solve the problem of unsupervised MD.
Okay, and because we have a small number of new viewers coming, and this talk is very short. And however, Xuanfei has a rich experience in NLP, and he also is a PhD candidate. And if you have any general question about NLP or about PhD life, you can also ask question in the chat room.
Sure.
Okay. And I have two technical problems about this method. Have you heard about the mix-up operation in it has been widely used in computer vision? I'm not quite sure you have heard. Mix up.
Probably I haven't heard about it yet. Probably
Okay.
Yeah. Can you just explain what it is?
Just you can apply. It is a little like the data augmentation. You can apply a linear interpolation between input, and also applying a linear interpolation between output, and then you can create a new input and output, and then you can create a new
data.
Create a new data.
So yes, so one thing to know is that NLP is a little bit different from vision in the sense that we have discrete data. So discrete input data. So we do not have like smooth and continuous data like images. So the way we try to do it in discrete input is that for example, we try to swap the order of words. We try to delete some words. We try to replace some words with some masked word, some fake words. So that's essentially the way we currently doing for data augmentation in NLP.
Yeah, great. Correct. It is actually NLP is not like the computer vision. It is a discrete space. And is it possible to apply such operation in hidden or in feature space? Yeah,
Yeah,
in
it
not,
is.
not in, yeah.
So from my experience, there has been some research trying to do that on the embedding space of the words, but generally the performance was not very good, and people actually do not use that method very often
Okay.
to that extent.
Okay. And another technical problem is uh, data diversification in general. And we know that NLP is, oh, not NLP, but machine learning problem is data hungry.
Yes.
It's data hungry. So we inside, if we don't have enough data, we have to generate. We need to solve such problem. And in most cases, no matter what data, no matter what algorithm, if you have enough data, your model can beat other
Yes.
fancy models. Yeah, great. And so I know that you utilize a model to generate data, and um, and in your model, I want to know whether there is a layer norm in your model architecture.
Yes, the transformer model has layer norm.
Okay.
Yeah.
We have parameters in layer norm, and is it possible to just add some noise? I'm not quite sure it is whether it is whether it works. Like if we apply some noise in layer norm parameters, and then we use such models to generate new data. And
yes. So this is essentially what some of these methods trying to do. So for example, we have like target noising, top K sampling, and top P sampling. They are all methods that trying to introduce noise in the model so that it can generate different outputs. You can generate different output from the models. And this it's not exactly the same as we adding noise to layer norm, but it's kind of falling in the same categories, which means that we're trying to introduce noise in some layers or some different part of the model, except the input, to generate new output that are different from others. And however, we observe that the result is not as good as our method. And the main difference here is that these top K sampling or top P sampling methods, they essentially using the same model, but just adding noise. However, our method is actually using multiple models. So essentially, it has like a completely different paradigm. And so our method is more related to knowledge distillation and model ensampling. So, if you know about model ensampling, we are using like multiple models to generate the same output. However, our method is a little bit different, is that we are generating multiple outputs using multiple models and train the final models on those outputs. So it also looks similar to knowledge distillation in that sense.
Okay, and the reason why I want to why I think of add noise in linear norm, because in computer vision we have a domain shift problem, and sometimes we utilize the batch norm to mitigate such issue. And we have actually from my personal shallow understanding, the parameter in batch norm implies some domain information, and for weight in convolution, it implies some common information. So I want to know whether it is possible has such properties in NLP. Maybe in layer norm parameters, it also contains some domain information, like different languages has some common information, but for German, for English, it has some domain information. And we can add noise on layer norm parameters, and then we can create a new domain. But it still can compare. Such model still can keep the languages for information, common languages information. It is my idea, but I'm not quite sure it can work.
Sure.
Sorry. Yeah.
Yeah.
And
yeah.
Okay. So for audience, do you have any questions? Maybe not just for this presentation talk, you can ask some question about the general NLP or general research questions. Okay. And Xuanfei, do you have any plans to do the further work based on the current work?
Sure. So we have a current work that is being submitted to ICRR, which is about pseudo parallel data mining.
Okay.
So in addition to this, we try to mine real parallel data from the bilingual data and then use that to jumpstart the UMT models. So in that way, we try to feed the model with more accurate real data rather than just using some model-based technique like this to generate synthetic data. So that is one way to do it. And also the current focus, our focus is more on low resource languages and or very distant languages like Indian languages, like Nepali, Sinhala, or some other languages like for example in Southeast Asian languages. So these are the real challenges for unsupervised MT, where we have very low resource and very low resource languages, and the languages are very distant from each other. We have the very completely different vocabularies like Latin and others. They have like character-based languages. So these are very challenging problems, and also the BLEU scores for all of these problems are actually very low. So at the moment, that may not be like commercially viable. For example, if you want to build a production level product for these languages, is currently still not feasible enough. So that is the focus that we are focusing on. And the idea is that we try to include the element of parallel data mining to improve the model on it and not relying less on synthetic data, because the synthetic data also have limits.
Okay, we have a message from Major, and
thank you. Yeah, that's great. That's great, Major. Yeah.
Okay, so for audience, do you have any questions? You can send send your question in the chat room, and we can wait for 1 minute. If we do not have, if you still have any question, you can send an email to ask Xuanfei.
Sure.
And Xuanfei, can you send your email in the chat room?
Sure. Yeah, feel free to email me any question.
Okay, it seems like we do not have any questions now. We're very fortunate to invite the Xuanfei to come to our SLS platform and present his work. And for audience, if you or your friends have such the publications or have research top research project to present, you can come to our platform and present your present outcome. And now I will end our talk today. And thank you.
Okay.
Bye.
Thank you, Away. Thank you.
Thank you, Faye. And thank you for audience.